going to see full wave rectifiers. Here what we are going to discuss is for every cycle of an AC input, how we are getting an output. So this is one line concept of this topic. So here both the halves of input cycles are used. So both the input cycles of alternating currents are used. There are two types of full wave rectifiers. The first one is center tap full wave rectifier, and the second one is bridge rectifier. So today we are going to see what the center tapped wave rectifier is about. Okay. Center tapped wave rectifier. So in order to build a center tapped wave rectifier, what and all we would be required is two diodes and a transformer, step down transformer, two diodes and load resistance, and to DC output we will measure their direct current output we will measure. So circuit for full wave rectifier consists of diode D1 and D2 connected to a secondary of step down transformer. The primary of a transformer is connected to input AC out signal. Is an input AC signal. Sorry. Okay. So hence I already mentioned, here we are using a step down transformer. Here primary coil is connected to an AC input, and the secondary coil is connected to two diodes, that is diode D1 and diode D2. So these are the basic arrangements we need. So now we are moving to the working part. So I will before I am reading out the theory, I will just tell the story of or concept before we are moving to the theory part. I will just tell what is actually happening here. So here the input we are giving to the primary transformer, primary end of the transformer is an AC input, right? So for an AC input, how the waves will be like, it will be so when we will put an axis, so the way alternating it will be the AC input. So here we will have positive both. Here we will also have positive cycle. Here we will have positive. Here we will have positive cycle and negative cycle, right? So for every positive cycle, there will be a change in the polarity at the ends of A and B. For example, let's say I'm giving an AC input signal. For the positive end of an for the positive end of an AC signal, here the terminal A becomes positive. So when terminal A becomes positive, then the terminal B will become negative, or it will have negative value. So when A is positive, here the diode D is forward biased, because for what is the concept of diode? When here the diode, it is a positive terminal, this is a negative terminal. So when you give the positive charges to the diode at the positive terminal, it will be forward biased. So it will be forward biased. In forward biased, the diode will the forward bias, the diode will okay, let me summarize one more time. For the positive half cycle, I will use different colors. So I will be using red color for the positive one. So for the positive AC input, here the diode will be forward biased. Here end A will be positively charged, so diode will be forward biased. If a diode is forward biased, it will conduct a current. That is the concept we have learned so far. So if the diode becomes positive bias, the current will flow through the diode. Like you can see here in the brown dotted lines, these are the current flow for the positive cycle of a AC input. Okay, so here the current will flow, it will reach here, and it will travel here, it will travel through the load resistance. As you can see, the dotted ones is the is where the current is forward biased, dotted lines. So it will flow in this direction. So when we simplify, when AC current is for a positive cycle of AC current, it will flow in this direction through the load resistance from C to D. Okay. Let's consider let's consider for the negative bias. For the negative half cycle, I will be using this blue color. So for positive half cycle, I used red color, and for blue, I will use it for the negative one. So we have seen for positive cycle. So negative cycle, what will happen if we have the negative half cycle of an AC input? For the negative half cycle, the end A becomes positive. The end A becomes negative, and the end B becomes positively charged. When B is positively charged, the diode D2 is forward biased. So when a diode is forward biased, it will conduct a current. So it will going to conduct the current in this direction. It will go like this, and it will pass through the load resistance to the direction C to D. So C to D. So let us summarize. For a negative half cycle also, the current is going to pass through the load resistance only in the direction of C and D. For the positive half cycle also, we saw that current is going to pass through the load resistance in the direction of C and D. So for every input, the current is passing through the same direction. So that is the concept here. What is the DC current concept? The AC current and DC current basic difference is what? Alternating current will have two halves, positive and negative half cycle. Both it changes its direction, but in direct current they won't be changing the direction. So that is what here it is happening. Let's move to the theory part. So walking, there are two halves of an input cycle. There are two halves of input cycle. In the sense, AC input, we have positive half cycle and negative half cycle. During a positive half cycle of input, one end like A becomes positive and B becomes negative. Then diode D1 becomes forward biased and diode D2 becomes reverse biased, same as we see now. As we know that when diode is reverse biased, it does not conduct current. It conducts only when it is a forward biased. So for a positive half cycle, A becomes positively positive value. So diode D1 is forward biased and D2 is reverse biased. Therefore, D1 conducts current and D2, that is at B, which has negative value, becomes reverse biased and does not conduct current. As a result, current flows through the load resistance in the direction C2 as shown in the figure. C2D as shown in the figure. For negative half cycle, during a negative half cycle, one end of the secondary, say A becomes negative and B becomes positive. So during negative half cycle, this diode B becomes positive and A becomes negative. So if B is positive means D2 is forward biased. So it is going to conduct the current. If A is negative here, it is not going to conduct current through the D1, because D1 will become negative bias. As we know, if a diode is a reverse bias, it does not conduct current. That is what exactly they are saying. Again, current flows through load resistance RL in the direction C to D. So again, the current passes through the load resistance in the same direction. Thus, during both cycle, current flows through load in the same direction. So in both of the cycle, the current is passing through the load resistance only in the same direction. That is C to D. The output voltage is developed across RL during the entire cycle. So for entire cycle means what they are meaning here? For entire cycle of an AC input. So let it be a positive half cycle or positive half or negative half of AC input. We are always getting an output voltage there. That is what they are meaning here. And we have to see the nature of an output voltage here. It is a pulsating DC voltage containing both AC and DC components. The input rectified output waveform is shown. So this is what we are discussing. Okay, let me zoom out. So this is the first one, right? Okay. So this is our AC input. The initial AC input. Second one is for a positive half cycle of the output of D1 when current passes to the diode D1. and the passes through the D2. At final stage, what we will be getting, for every half cycle, for every half cycle of an AC input, we are getting an output voltage, that is total output as like this, total output as like this. So we can conclude that through a full wave rectifier is something which we get DC voltage, DC pulsating DC voltage containing AC and DC components here. This is the simple this is the concept behind the full wave rectifier. Then in the next video I will be explaining, as we have seen, there are two types of full wave rectifiers. Here we have seen center tapped full wave rectifier. The next video I will be discussing about bridge rectifier, which is also very easy one. So that's all for the video. If you have any other topics to be covered, please comment in the comment section. Okay, thank you.